Hi there, and welcome to this lesson on Pure Mathematics 2. In this lesson, we're on Chapter 4, 4.4, and we'll be looking at how you solve a variety of different types of question using the binomial expansion. So that is the binomial expansion. Binomial because you've got two terms in a bracket to some power, and if we expand that bracket, this is what we would get, where the general term is NCR, a to the power of n minus r, times by b to the r. Okay, let's have a look at an example. Find the first three terms in ascending powers of y in the expansion of 1 plus y times by 3 plus 2y to the power of 6. Now, the way we're going to do this is expand this second bracket using the binomial expansion, but we won't do the whole of the bracket, we'll just find the first three terms. We're not going to need the others for the answer, so there is no need to work them out. So we'll find the first three terms of the binomial expansion for this, and then those three terms we'll have in a bracket. We'll multiply that by this first bracket and collect everything together. Okay, I'll let you have a go at seeing if you can make sense of that. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look at this. So, as I said, the first thing we're going to do is just expand 3 plus 2y to the power of 6 using the binomial expansion. So the first term, a to the n, will be 3 to the power of 6. The second term will be this. The third term will be that. There are higher order terms, but we're not going to work them out because we're not going to need them in the answer. Ultimately, we're only going to need the first three terms. So these extra higher order terms are not necessary to calculate in this question. Tidying these numbers up using the calculator, 3 to the power of 6 is 729. 6c1 times 3 to the 5 times 2 is equal to that, and 6c2 times 3 to the 4 times 2 squared is 4,860. Now we're going to multiply those two brackets together. 1 times each of those three things will give me the first three terms. Y times each of those three things will give me the second three terms. There are extra terms, but as I say, we're not going to need them in the answer because we only need the first three terms for the final answer. The constant term is just 729. The y terms are those two terms added together, and the y squared terms are those two terms added together. That gives us the first three terms. We don't need the y cubed term, that would be the fourth term, and we don't need any higher powers either. So that will be the answer. Okay, example 2. Find the coefficient of y cubed in the expansion of 1 plus 2y to the 5 times by 3 minus y to the power of 4. Now, there's a lot more going on in this question. We're going to have to use the binomial expansion to expand this first bracket. We're also going to have to use it to expand this second bracket. However, on both occasions, we'll only expand these brackets up to the y cubed term, because if we're going to find the coefficient of y cubed, we won't need any of the higher powers. So we'll need to find the first 4 terms of the binomial expansion for this bracket, the first 4 terms for this bracket. That'll give us 2 big brackets being multiplied together with lots of terms. But you don't need to multiply everything together. When you get to the end, just keep an eye on what you're trying to find, which is the y cubed terms. Okay, I'll let you have a go at making sense of that. So pause the video, have a go at this, and then come back to me when you're ready. Okay, let's have a look. So first of all, we're going to expand 1 plus 2y to the power of 5 using the binomial expansion. The first term will be 1 to the 5, second term's that, third term's that, the fourth term is that, and the fourth term is the y cubed term. Now, for finding the coefficient of y cubed, we're not going to need the higher powers. Tidying these up using the calculator will give us 1 plus 10y plus 40y squared plus 80y cubed. Then we do the same thing for 3 minus y to the power of 4. Do be careful with the minus y. The minus does need to be included as part of the term. Those would be the first 4 terms. Again, that takes us up to the y cubed term. We're not going to need any higher powers because we need the coefficient of y cubed ultimately. 3 to the 4 is 81. Multiplying all this together will give me minus 108. Multiplying all this will give me 54. And multiplying all this will give me minus 12y cubed. So we've now expanded both of these brackets using the binomial expansion up to the y cubed term. We need to multiply them together now. So multiplying them together would give us that. We don't need to multiply everything out. We're only asked to find the coefficient of y cubed. So we just need to see exactly where that's going to come from. And it's going to come from 4 places. It'll come from when I do the 1 times by the minus 12y cubed, that'll be a y cubed term. The 10y times by the 54y squared, that'll be a y cubed term. 40y squared times the minus 108y, and 80y cubed times by the 81. But those 4 pairs are the only ways in which I can get y cubed. So they're the only 4 pairs I actually need to multiply together. So the 1 times by the minus 12 is that, 10 times 54 is that, 40 times by the minus 108 is that, and 80 times the 81 will give me the 4th term. Those are all the y cubed terms. There aren't any more. I just need to collect them together, and that'll give me 2,688 y cubed. So the coefficient would be 2688. Example 3. Now, a little bit trickier this. We've got a value here, c, and we don't know that value. But what we're told is that in the binomial expansion of 2c plus x to the power of n, that the coefficient of x squared is exactly the same as the coefficient of x cubed. We're asked to do 2 things. First of all, we're asked to show that n equals 6c plus 2. And then secondly, we're told the value of c, and we're asked to find as a simplified fraction the value of the constant term in the expansion. Now, we'll consider part 1 first of all. Part 1 just uses the information in the question. So we're going to work out the coefficient of x squared in the normal way. It'll involve c's and n's, but don't worry about that. We're then going to work out the coefficient of x cubed in the normal way. Again, it'll involve c's and n's. Because they're the same as each other, we'll be able to equate them to create an equation. When we solve that equation, it should simplify to give us n equals 6c plus 2. Now, I'll let you have a go at doing that yourself. As I say, it's a bit tricky this, there's quite a lot going on. But have a go, pause the video, and come back to me when you're ready. Okay, let's have a look. So first of all, we're going to work out the coefficient of the x squared term. That'll be nc2 times by 2c to the power of n minus 2 times by x squared. That'll be the x squared term. Now, the significant thing really is what we do with the nc2. We don't know n, so we can't work out the value. But what we can do is use this little expansion for how we calculate NCR. So nc2, using this, will be equal to n factorial divided by 2 factorial times by n minus 2 factorial. And then we'll have the 2c to the n minus 2 and the x squared. This can be simplified. N factorial is n times n minus 1 times n minus 2 and so on. So it's n times n minus 1 times by n minus 2 factorial. And the reason for writing it down like that is we've got n minus 2 factorial on the bottom. So these two n minus 2 factorials, they can cancel with each other. And that'll leave us with n times n minus 1 on the top. 2 factorial is just 2, so we'll have 2 on the bottom. So that's the x squared term. We do the same thing for the x cubed term. The x cubed term will be nc3 times 2c to the power of n minus 3 times x cubed. And again, nc3 we can write down using the definition of NCR. It'll be n factorial over 3 factorial times by n minus 3 factorial. Haven't done anything with these two terms. We do something very similar to simplify this. So as we did with the x squared term, the n factorial term I'm going to choose to write as n times n minus 1 times n minus 2 times by n minus 3 factorial. Because then I can cancel these n minus 3 factorials with each other. And that'll simplify to n times n minus 1 times n minus 2 on the top, and 3 factorial is just 6. Haven't done anything with these two terms. So that's what we've done so far. We've worked out the x squared term, which is this. We've worked out the x cubed term, which is this. And in the question, we're told that the two coefficients are the same as each other. So the whole of this expression must equal the whole of that expression. We just write that down as an equation. We say the two coefficients are equal. Now that's quite a mess of an equation. The easiest way to move forwards with this is to collect all of the n's on the one side. So the n minus 1, the n minus 2, I'm going to leave over there. This n and n minus 1, I'm going to divide by, bringing it over here. Everything else, I'm going to move to the left-hand side. Now, when I do that, this is what I'll get. So the 6 has swapped sides, and I've multiplied by it. That gives me 6 times 2c to the power of n minus 2. The 2 I've left where it is. The 2c to the power of n minus 3 has moved over to this side, and I've divided by it. And on the right-hand side, I've just got the n's. N times n minus 1 times n minus 2, and this n and n minus 1, I've divided by, bringing them over here. The reason for doing that is it's then possible to simplify things quite a lot. Looking at the right-hand side, first of all, these two n's cancel with each other. These two n minus 1s cancel with each other. So that just leaves me with n minus 2 on the right-hand side. On the left-hand side, I've got 6 divided by 2, which is 3. And then I've got 2c to this power divided by 2c to this power. Well, I'm just using the normal rule for powers here. If you've got one power divided by another, you subtract the two powers. So I'll get n minus 2, the top power, take away n minus 3, the bottom power. N minus n is 0, minus 2 minus minus 3 is minus 2 plus 3, which is just 1. So the left hand simplifies to just 3 times 2c, which equals n minus 2. Multiplying the brackets gives me that, and rearranging that gives me what I was asked to show, that n equals 6c plus 2. Okay, a lot of work then. That's part 1 done. Part 2 says, given that c is equal to 2/3, find as a simplified fraction the value of the constant term in the expansion. Now, the constant term, what's that? The constant term is the term that doesn't have any x's in. So it's the term which has just got c's in it. It'll be the very, very first term in the binomial expansion, so a to the power of n, or in our case, it'll be 2c to the power of n. So that's the constant term, 2c to the power of n. I need to work out c, I need to work out n. Well, c, they've told me, that's 2/3, so I can substitute that in straight away. N I can calculate from part 1, because we've been told that n is equal to 6c plus 2. So I can calculate n, put everything into there, and then I can work out the constant term. There's very little going on here, so a lot easier than part 1. Have a go, see if you can do it yourself, then come back to me when you're ready. Okay, let's have a look. So as we said, we need to work out n. Well, n is equal to 6c plus 2. We've been told that c is equal to 2/3, so n is equal to 6 times 2/3 plus 2, which gives us 6 for the answer. So n is equal to 6, c is equal to 2/3. The constant term then is 2 times by 2/3 to the power of 6, which is 4/3 to the power of 6. That'll give us 4,096 over 729. And that is the answer. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 70 and have a go at exercise 4D. Thank you very much for listening, and cheerio.